Excellent work on completing your mission, Agent. Let's quickly go over a debriefing so others can see how you were able to accomplish your tasks. The first thing we needed to do was to unzip the file. To do that, we can easily just import shutil and then call unpack archive function from that. We will say unpack archive and then put in the actual zip file location. In this case, we'll say mission orange files and then the unzip me for instructions. And let's go ahead and then give it a location to be placed in. We'll just put it in the extracted content. And then finally, we need to clarify that it's a zip file. So if you run this, you should now be able to see the extracted content. And we can check this by saying import OS and then saying OS list directory. And you'll see here that if we keep going down, we can see the extracted content that we just created. So that directory now exists. All right, let's now check to see what files are in the extracted content. We're going to say os.list directory, and we'll actually then pass in the extracted content so we can see what's inside of that. And here we can see there's 5, 4, instructions.txt, 1, 3, and 2. Let's open this instructions.txt and see what's inside of it. We'll say f open, and we're going to pass in the extracted content and then instructions.txt. And we can just use tab autocomplete to do this. Let's read this file and say f.readLines so we can see everything. All right, so it says if you're reading this, and let's actually print out all these lines. So let's run this again. We'll open this file and then say lines, and then for line in lines, print line. There we go. So if you're reading this, we were able to successfully decipher from the blog post on the Goldbugs website to find this link, which led us to that zip file. After unzipping this file, we had this instructions.txt file. And if you take a look at the other folders, there's actually random text files in them. So inside of 5, 4, 1, 3, and 2, there are random text files. And hidden within these text files are 2 links. And we need to be able to use regular expressions to find the URL links which lead to the next phase as you go through every text file programmatically. One of these links is going to lead to a CSV file and another to a set of instructions for that CSV file. And it tells us that the links are going to be in this form of URL. It will be a drive.google.com, open, and then some sort of ID. Notice here how we have alphanumerics, so there's numbers, letters, and underscores. And we have HTTPS, and then we also have some sort of Google Doc. So HTTPS docs.google.com, document, and then some sort of alphanumerics. So we have starts with HTTPS and then a series of characters. So we'll be able to use this information for our regular expressions by realizing that inside of these files, we're looking for something that starts with HTTPS. Then we'll download that CSV file and follow the instructions in the other link for next steps. So let's see if we can do this. The first thing we want to do is figure out a regular expression pattern that works for finding these sort of links, something that starts with HTTPS. So we will import regular expressions, and let's create our test phrases. So test phrase 1 will be this first link here. And then test phrase 2 will be the other link. So we're going to be using these as test strings, and then we'll check different patterns against them. And if we are successfully able to grab this entire URL from the pattern, or using the pattern, I should say, we'll be able to see that we will be able to grab the pattern within any text file. Now we realize the pattern does start with HTTPS, so let's check if that works. We'll say R, and we're just looking for HTTPS : //. So if we say test, well, let's say RE find all, and we're looking for the pattern inside of the test phrase. When you run this command, you'll see that there's basically just HTTPS and none of the actual remaining URLs there. So we need to add a group of characters to look for after HTTPS. And there's many ways you could write a regular expression for this, but one way to think about it is just HTTPS : / and then just group together using these square brackets or braces, and then with a plus sign, we're looking for any number, one or more, of the following. We'll look for dashes. We can see there's a dash right here. There's also question marks and /. So we'll say the following: question marks, /. There's also underscores. There's equal signs, and we can put a period dot for a wildcard if necessary, and then finally we can say something like \w. And let's run this now and see if we find it. So here we go. If I add a bunch of stuff here, basically say look for any combination of these after HTTPS, I see I have now the full URL and it matches up here. Let's try it with test phrase 2 and make sure it also works. And if we run that, we also see that we get back the full URL. So that's working well. Now what we need to do is basically go through every single text file and search it for this actual pattern. So let's make a function we can call, so we can call this pattern easily. We'll create a function called search. It takes in a file, and the pattern we'll be using here is equal to what we just wrote up here. So we'll say pattern is equal to this. And this actually doesn't really need to be a parameter in your search function. We'll open the file. Open the file. We'll just read the file. That way we don't accidentally edit it. Then we will say the text is equal to f.read. So read this as a string. And then if research pattern text, basically indicating if I have a match object. So keep in mind, match objects can actually be used as booleans. So lots of ways you could write out this logic. You're going to return research pattern and then text. Else we'll just return a blank string. So what this function is going to do, it's going to accept a file. It's going to open that file, read that file, and then it's just going to search for the pattern in that file's text. And if it finds one, it's going to return the pattern itself, basically the result, that URL. If not, it'll just return an empty string. Now what we need to do is use osWalk to walk through all the files here, because if we come back up here, notice there's 1, 2, 3, 4, 5 files, and each of those, well, 5 folders really, and each of those folders contains many random text files that we need to look through. So we will do the following. We'll say import OS, have my results as an empty list, and we'll say for folder, subfolders, files in OS walk, and I'm going to walk through the extracted content that I have here. So let's scroll up. Where did we actually extract that? It's right here, the extracted content. So we'll just copy this, come back down here and say OS walk through that extracted content. Then for F in files, I need to define the full path. So the full path to that file is going to be equal to the folder it's in, plus, since I'm on a Windows computer right now, // plus F. So what this is saying is construct the entire file path to that file, otherwise you'll get an error when you're trying to open it. Because what I'm going to do is say my findings, or whatever you want to call this variable, is equal to search on the full path of that file. And then I'm going to append my findings. All right, so let's break down what we're doing here. We're using the osWalk function to walk through the extracted content of the zip file. If you take a look at the extracted content, it's just a bunch of random text files. And if we look through each of these files, in order to construct the entire full file path so that we can open it when we call the open function here, we're going to grab the name of the folder we're currently in. Then because I'm on a Windows computer, I'm going to add 2 backslashes. If you were on Mac or Linux, you would just add a single /. and then I will add the actual file name. That constructs the full path of the file, which is what I'm going to pass into my search function. And my search function here is just going to open that file, read the text, and then do a regular expression search. And if the search name is confusing you, you can say search for pattern, and then down here I could just call this search for pattern. So it's going to search for pattern in that full path. Those are my findings. Then I'm going to append my findings to the results. So let's run this, see if it works. Looks like it worked. Then we'll say for all my results, because if we look at the length of results, it's going to be 121. But a lot of these are just empty. So let's take a look at the first 10. One of them we have a match object right away, but others are just empty strings. So let's actually say for r in results, if the r is not equal to an empty string, go ahead and print the results. So we can say r.group, because remember, if you have a match object, which is r, note here it's saving match objects, you can just group it together to actually grab the URL. So we're going to run this, and we see now we have 3 links here. So let's check them out. We'll open each of these and see if we actually find them. So one of them was not found because it's actually, if you take a look at it, it's the example link that was shown here in the instructions, which is not an actual functional link. But if we take a look at the other 2, looks like we have instructions for downloading the CSV file. So we can go ahead and read this for our next mission. And the other one is the CSV file itself, meaning we'll need to learn how to work with CSV files for your next mission. Excellent work so far, Agent. Let's quickly have an overview of the entire debriefing. So to begin with, you were given this zip file that you had to unzip. Once you unzipped it, you were able to realize that there's an instructions text file. And if you read that instructions text file, it basically tells you that inside of these other folders are many other text files, and inside of one of those are URL links. And you need to find 2 of them that are in this format, a drive link and a docs link. You were given the hint that they start with https://. However, if you just look for that, you'll just find https. So what you can do is use regular expressions to basically indicate that you're looking for anything that follows https. One of the tricks they had to realize, though, was it's not just technically all alphanumerics. There's also question marks and equal signs and dashes to include there. So we created our pattern, and then we had this find all, so we could actually grab the URL. We created a function that, when given a file, it searches and returns the pattern or the match object or an empty string, depending if it finds the pattern match or not. Then we used OSWalk to walk through all those text files, and then if we found something, we went ahead and appended it to our findings. Something else you could do here is only append if the findings was not an empty string. So what we could do here is also the following. We could say if findings not equal to an empty string, then append it. So if I were to run this again and then check the length of my results, now I only have 3, and I can just check my results for the links themselves and then go for match in results, print match, and then group the result itself so I can get those actual links. And those actual links, one of them was the instructions link, which is not open to anything. The other ones are the link for the download CSV, the instructions, as well as the CSV file itself. Okay, excellent work. We'll see you later in the field.